It started in 2016 after we tried to go after a proposal that was in the watershed I grew up in. We didn't win the project, but that's really what started Tailwater. And Tailwater has been our full-time gig since 2017. All right. With that, I'm going to start my slideshow because we'll get into a lot of these other pieces. Can I share my screen? Oh,
Please
there we go.
do. Yeah.
We'll send the request. All right. And I'm going to move you guys over here so I can still see you.
I think we're tracking.
All right. Now we're backwards, aren't we? Are you guys seeing the slideshow or the presenter
What
notes?
questions should I ask during a stream restoration design review meeting? Yeah, we're seeing the notes. We can see your slide. It's fine. But if you like to, well,
Let's go that direction.
here, click on the
No,
screen picture. Oh, sorry.
I'm getting it on both screens. We'll just share from the other screen. All right. We'll give you screen two instead, which actually has the slideshow, not the presenter notes. Put you guys over here. All right. So I find myself talking a lot about tools and technology these days. And part of that is because through this bump in the road, I have ended up doing a little bit of programming and using a lot of the tools. In this, most of the conversations have come from real life projects and real life situations. I have completely changed the projects, the people's names, and the frameworks just for illustrative purposes. So, as part of this, one of the hot topics these days is AI. And so I asked my friend ChatGPT, what questions should I ask during a stream restoration design review meeting? And of course, ChatGPT does not hold back on words. And it took a lot of formatting to get all of this text on one page. But we all have to be prepared for somebody to come to a stream restoration meeting, stakeholder meeting, anything, having asked ChatGPT these questions. So all projects start with a problem statement. Somebody notices we have a problem. Either it's on a national level or a local level. And in today's framework, we get together our stakeholders and they all have differing backgrounds. And that was one of the things we really emphasize on projects is that people's backgrounds really do matter. Some of them are concerned with cost, some of them are concerned with their favorite tree. And then, of course, many of our projects these days intersect with infrastructure. And a typical question I get is, can you give me a cost estimate? Most people are concerned with, well, how much is it going to cost? And we typically use a cost estimate these days between $250 and $1,000 a linear foot. So I asked my contractor friends because everybody wants, well, I want a better, more detailed estimate than that. Never mind that we're at the 10% level. And he wants to know how much earthwork, how many root wads. And then, of course, his response is, well, I can't get one of your supplies. And of course, as we all know, diesel prices are through the roof and very variable. And then we work with some other clients that will go back in time and they, of course, Google a manual and come to the meetings and say, well, you have to do this. Never mind that you work in stream restoration every day or you have expertise in one area of this or another. You have to follow this manual, even though it may not be applicable because we've learned so much more over time. And that's one of the places technology really brings us problems is that it keeps older material in front of our stakeholders. And so it gives us a large mountain of information to try to overcome these assumptions. Most of our projects start with a geomorphic reach survey. And what we're going to try to figure out is what is the cause of the problem ideally? Because if it's not broke, we don't want to fix it. And your typical geomorphic assessment includes a couple cross sections, a longitudinal profile, maybe a bar sample, some active riffle pebble counts. Maybe you do a Banks assessment, but it's pretty sparse data. And this is where we really get into technology. So we have used drones. We own a LiDAR drone, and we are able to collect a lot of data really quickly by flying that drone. However, with lots of data comes lots of data processing. And so a picture can save us 1,000 words, steps, or minutes, but it may also require additional time in the office. So we have to consider when using technology. Drones don't replace fieldwork. When we do fieldwork, we're looking at our sites, we're thinking about what's going on. Ideally, we're using technology to let us take our heads out of our apps and observe and think about the problem. I don't know about any of you guys, but one of the problems I get is you get data collection mode. Oh, I gotta follow the water surface. I gotta follow the Tailwaggg. You're really paying attention to that and not looking around the surroundings and seeing what's going on. And that's one of the major goals of using technology. Going back to our geomorphic assessment data, I don't know about all of you guys, but if I don't have to scramble through a rose bush, I'm not going to. And so we pick and choose cross sections based on what we see in the river, but also what we see on the banks and how much of a pain it's going to be to actually collect that cross section. So inherently, cross-sectional data is biased. We collect reference reach data, and please don't use this data. I made it all up. That might have a minimum, a maximum, and then we calculate some averages, and then we apply that, our site to our reference, and look at departure. And then we, in theory, design our site plans to address that departure. Often this is done with typical cross sections that are coming from those averages in the table earlier. Back in the 1990s, it was pretty typical to just use typicals. And, you have small groups. They all have very similar backgrounds, so they can kick the dirt, have a conversation, and lo and behold, successfully implement a project. And there are many people that can do this. As our projects have increased in complexity, we have transitioned to the breakline spreadsheet. There's various other proprietary applications that have been used to do stream grading. So we can do this in 3 dimensions. We have models. We can put that in HEC-RAS, and we can do all sorts of evaluations. And I'm going to talk mostly towards stream tools and corridors, and then do a little bit of preview for Stream Tools Flex, which I'm currently working on. So one of the challenges we took on with the COVID pandemic was taking this breakline spreadsheet, which David Beidelschbach, Mike Geenan, and others developed to do grading for channels that includes riffles and pools. And I think it was in about 2019, we were helping David with some projects, and he had, I think, 5 interns. And one of the things we really noted was how much time the interns were spending trying to learn about managing text files to use a spreadsheet to bring it in and out of CAT. I was like, well, you know, we could probably put this in CAT. And so that was where Stream Tools was born from, was figuring out how to put it into CAT. Um, Small global pandemic canceled one of our projects, so all of a sudden we have time. And now this is available as an add-in to Autodesk Civil 3D. As our groups become larger and more diverse, we're having more and more questions. And we're having more and more complex projects with infrastructure, endangered species, material availability. So as our projects require tighter tie-ins and increased complexity, we need technology to be able to model these systems prior to mobilizing construction equipment. And you can, at this point, the technology exists that that excavator has a GPS unit mounted on it, and that bucket will stop at the grading limits. Just because we can put something into a computer doesn't necessarily mean that it should start there. Often it helps to draw things out. We've got a whiteboard in the hallway, and we'll draw it out and think about what's going on, where our computer outputs are wrong. Where computers really come in is they're really good at doing repeatable tasks. So you do it once or twice, you figure out a process, and then you let the computer do the rest of it. And that's exactly what Stream Tools, Corridors, all of those tools do. So I brought in this example project. This is the grading sheet from one of the projects we worked on. And so some of the technology we routinely use includes RTK GPS. We did all the geomorphic survey. The existing ground was from LiDAR we collected. We often use 3DEP, but this particular site had a lot of earthwork moved, so 3DEP was no longer representative of conditions. Evaluated flood risk with HEC-RAS 2D, planting zones, very detailed. It was constructed with GPS-enabled equipment, which wouldn't have been possible without this detailed site plan. All the channel grading was done with stream tools. So I think one of the takeaways was technology should allow us to do more analysis. It should allow us to paint clearer pictures for our stakeholders, evaluate alternatives, and I think really emphasizing that it can save time and it can save money, but it doesn't always. Technology always requires synthesis, and one of the big things that technology helps us do is generate quantities. If you draw your toe wood to scale, you can literally count the toe wood in the drawing to make sure that you have enough. But that doesn't account for various sizes of trees. And it doesn't account for the human factor, which we always have to have in. And so in many projects, you develop and spend all this time putting together plans, and then your contractor says, well, but I know what it says. I'm not going to read the plans. And you get to the end of this and you're like, why do we have materials left over? And why does this not look like the plans? So although you have detailed plans, it doesn't replace construction observation. And it doesn't replace time in the field. We often end up with stakeholders that think they understand what's going on, but it's really hard to get them out in the field. In which case, you tend to not have as much of a realistic vision. We sometimes end up with the problem, and this is again AI, and then the other one's a real picture of where a client's images of the project come from. However, sometimes you end up with sites that look like that, and you spend a lot of time and also money trying to explain to a client why their site probably isn't going to look like this. So, as part of what we've done at Tailwater, is that we've watched people, we've helped with teaching people how to use Civil 3D. We've got a lot of experience doing that. And recently, there's been we've made a real big push to make this information available because just because you're young doesn't mean you know how to use all the technology. And so you've got to have resources available to learn this. One of the things we introduced this year was a Teachables website that walks a user completely through the Civil 3D design process that we use. If you've been on YouTube, we've got a similar series available on YouTube for free. The advantage of switching to a Teachables platform was it enabled us to provide files and more background information. And we were able to have an editor go through it successfully, completing the river design with exactly zero stream restoration or Civil 3D experience. So that's been really awesome. We also created the station offset plugin for QGIS so that we could introduce using RTK GPS as part of the wildland hydrology short courses. This was a solution that made technology not a barrier to students, but we could utilize that technology to collect data and collect a lot more data than we would be able to with a laser level. In this, I've talked a little bit about Stream Tools. Stream Tools is an add-in for Autodesk that we do stream grading with. It basically utilizes 2, 3, or 4 cross sections to do channel grading. And we've added some options over the years. I've also written this rim utility as well, trying to allow everybody to have access to these tools. We originally started with Stream Tools as we were going to give it away. And I asked some people to try it out. And they wouldn't try it. They wouldn't even open it. Like, well, I guess we'll sell it. So we put a $100 price tag on it. And finally, we got some buy-in with people trying things out. Um, we have this inherent um, process as humans that, if it's given to us for free, it has little to no value. But if we pay for it, then all of a sudden we have some skin in the game and we are willing to ask questions, we're willing to make comments. And so putting it on the Autodesk App Store enables these tools to be available to everybody. And the breakline spreadsheet was always available to everybody, but you had to have a personal connection to use it. By having it on the App Store, you don't have to know me. You can just have access to the tools. And it kind of levels the playing field for both large and small businesses to do stream restoration. As the last piece of this, I wanted to share with you a little bit about Stream Tools Flex. So as we've watched people use Stream Tools, been asked questions, asked for features, I've really changed everything about Stream Tools. And I was going to bring this up. Let me get this up. I got a little preview for everybody. So this is the new interface for Stream Tools Flex. One of the things that was requested was including hydraulic parameters. So all of those are included. We can edit cross sections, draggable points, slopes. I'm still working on the interface. the addition of having as many cross sections as you want, being able to do multiple reaches, all of that will be built into Flex. More saving options and some of those things. And so one of the other challenges, and this is going back to how we collect reference reach data, stream tools and breakline spreadsheet create this reference bankful line to keep the pools flat. And it's really hard for people to imagine what that thing is. And it's kind of in the background. And so I'm going to change things up and we're going to do a Tailwatt and bankful profile design. So we're going to sandwich it between those profiles. So we're comparing our reference data a little more closely to our designs. New calculators, new cross-section variations, and then the ability to save the file to Civil 3D or just a text file. The cool part about that is that the tool doesn't have quite all the same functionality without Civil 3D, but it doesn't require Civil 3D. So we can do some more geomorphic analysis without having a subscription to Civil 3D. And I think I covered most of these. One of the challenges we're working on is improving those transitions from typicals. Um, the whole purpose of this is so that you can iterate and to be able to shift your focus from arduous file processing to thinking about your design and how your design addresses the project objectives. And so one of the things we're trying to address is, the transitions with those typicals. So, and that is all I have today.
So sorry about the interruption there. That
Quite
was
all right.
great. I love that, Andrea. Thanks for the share. I didn't know you were going to be speaking about the tool you guys put together and have been working on, but I have experience with it, and we have experience with it, and it's been a great tool. Speaking of as a communication device, a lot of folks who came up in the world of streams maybe 10 or 20 or more years ago have this different relationship with the metrics that we calculate and the things, the data we collect. And something that I've been challenged with these days is trying to recreate those connections and new practitioners and younger practitioner, early career. We have people that come into the stream sector that say, "Oh yeah, I've never had open channel hydraulics classes," but yet they're finding their way into doing modeling, and they find themselves doing sophisticated modeling. It's like, wait, let's let's back up. So sometimes, these engineering tools make things readily available to us. It reminds me of like, say, the wristwatch. Somebody invented a clock and we're able to keep time, and they were able to be more efficient and put it on a wrist, and quality control enabled it to everybody's keeping the same time. But I don't really know how that clock works, right? It just tells me the time. So to the point,
I
bringing solutions and
don't
good
know where it came
stewardship
from.
bringing good stewardship uh, out front beyond just the transportation sector where we see a lot of offsetting mitigation, but practitioners, people who have land, who confront streams, who are dealing with fluvial geohazards, who are dealing with, collateral damage from prior management decisions and so forth. They might be really good at something else, and this is not what they do at all. So I'm finding that more tools and using our tools not just as design tools but for communication. And I like the picture, the slide where you showed people actually still getting into the stream. There's no replacing the field work. You still need to go there and connect with it. But getting your clients involved, getting your clients to be on site and to really look at it with you in tandem. And you know I don't know. I just think that the tool is useful, is very useful, but I think with it is the mindset of teaching. So I'll just leave it at that. I thank you. That was a nice presentation. This, I like the pictures of the dog.
Let's see, did we
Thank,
lose? I think we might have lost Andrea.
I think she might have just switched off of her platform. Yeah. Well, do we have a questions? We can go ahead and populate questions. I think Andrea's probably trying to log back in, so we'll be tracking for her.
Yeah, I know I've got a couple questions, but does anybody else have any questions that we want to make sure to ask once Andrea hops back on here?
I'm curious about their Flex tool as an editor. She did put up um, a barcode, or what do we call those anymore?
Oh, the
A
QR
QR
code.
code. There she is. Hey,
Andrea, yay.
you made it back.
Internet went out.
Oh
So
no.
I was just going on and waxing and waning and going on and on and on about the thank you. That was a good presentation. I love the communication. That's where we are, I feel like, in the sector. And if we really want to advance stewardship, it's engaging people who this is not their primary thing. And your tools enable us in the work setting. People I work with that are learning. It's a good platform. But not they might not understand something as they move forward. I was saying good, yeah, as like for instance modeling, some of our modelers had never taken a open channel hydraulics course in their form of engineering, but yet that tool enabled them to understand what their questions are, and go back and backfill, as I think your tool has done in our case, and a number of cases, encourage some of the users of the tool, some of my better users, the people I work with that are more proficient with the tool, maybe have less proficiency with open channel hydraulics or some of these things, but this tool gives them a place and an identity, and it encourages their learning outward.
And also, I mean, like with the hydrology analysis and hydraulics, with generating break lines and being able to do things in Civil 3D, we're able to throw our projects in HEC-RAS and do a two-dimensional model pretty quickly, just to look at what's going on. We don't have to be exact. As long as we understand the assumptions and what we're getting out of it, it helps us identify those kind of pain points that might occur in a project. I mean, we've fixed curves and done small adjustments to alignments to help our channel be a little bit better interaction with our floodplains.
Jumping in here, Andrea. Thanks. I loved hearing about those tools and kind of the process and using them. I have a couple questions that might kind of complement each other. So I think one of the topics that you hit on was kind of the like tools versus people, and you kind of need both of them. So I guess my question would be, how do you determine when to pull in that technology and when to lean on the human piece of it, and kind of what's that balance look like? And
So
maybe,
if the tools help you answer the questions that you're going to be asked or you are being asked, then it makes a lot of sense to use those tools. If you are not going to be able to achieve appreciable improvement in your project outcomes from a tool, you definitely need to ask yourself, is it worth the time? And I think we try a lot of different things and we create a lot of data pollution with trying those things. And if at the end of the day you say, well, it didn't change my outcome, then you really should consider whether or not you should use it on the next project.
yeah, I appreciate that. Thanks.
Did you have a second question, Molly? Another?
It was kind of a two in one. I think she hit both of them.
Okay. Um, I wanted to mention you put up a QR code. Is there any way we could kind of keep that? And I think what typically with the recordings, we leave a screen, like there's a picture that says, oh, it's this recording. I think if we could leave that QR code, because you guys have a lot of good information, and unlike a lot of people who provide proprietary solutions, you guys have a real breadth of an ability to share. So I just want people to make sure they can get in touch with you guys.
So let
Maybe if
me
you have that
see
back
if I
up.
can successfully do this. Let me see if I can just copy it and paste it in the chat.
That would be perfect. And then when I post your video, your talk, maybe it'll be in there, but maybe I can also
So this is the Foreman
correct them.
process.